You've heard it a million times, right? Stress is the enemy. It's this thing we have to manage, reduce, and if we're lucky, just get rid of. But what if that's only half the story? What if stress is actually one of the most powerful and sophisticated tools your brain has for navigating the world? Today, we're diving deep into the stress paradox. So let's just kick this off with one big question that's going to frame everything we talk about. When you feel that jolt of anxiety, that feeling of being completely overwhelmed, is that a bug in your human operating system, something that needs to be patched? Or is it a fundamental feature designed for a very specific and honestly vital purpose? To really get our heads around this paradox, we first have to pop the hood and look at the biology. We've got to understand the basic machinery our bodies are working with to respond to any challenge, whether it's big or small. Okay, so at the absolute heart of all this is something called the HPA axis. Now, I know it sounds super complicated, but just think of it as the command and control center for your body's entire stress reaction. It's this beautifully orchestrated link between your brain and your adrenal glands. And this command center kicks off a fascinating chain reaction. It all starts when your brain senses a threat, and that could be anything, a looming deadline at work or a car suddenly swerving into your lane. That perception flips the switch on the HPA axis, which sends a signal all the way down to your adrenal glands to release hormones like cortisol. And you can think of cortisol as your body's own high-octane rocket fuel. It floods your system, mobilizing tons of energy so you can deal with the threat head-on. And then, once the danger is past, this feedback loop signals the brain that everything's cool, shutting the whole system down to save energy. But here's a really crucial point from a 2012 paper by Herman and his colleagues. They make it clear that this whole thing isn't just a simple on-off switch. No, it's way more sophisticated. It's a network designed to be flexible and adaptive, not just some clumsy alarm bell. Of course, we all know this elegant system can be pushed way too far. So what happens when that alarm gets stuck in the on position? Well, this is where we shift from function to malfunction, and we see how overwhelming stress can leave a lasting physical scar on the brain. And this slide really lays out the critical difference. In a healthy response, your prefrontal cortex, that's the rational CEO part of your brain, is in charge. It keeps the amygdala, which is your fear center, in check. But after some serious or chronic stress, that whole relationship just flips on its head. The amygdala becomes hypersensitive, kind of like a smoke detector that goes off every time you make toast, while the prefrontal cortex becomes underactive, losing its ability to calm the whole system down. And this leads us to a really powerful idea that researchers call the scar hypothesis. The theory is that trauma doesn't just create a bad memory, it can leave a persistent biological trace, a literal physical scar that fundamentally changes how you react to stress forever, making you much more vulnerable. Your system doesn't just reset to factory settings. And these scars are absolutely physical. Neuroimaging studies show that chronic stress literally remodels your brain. It can build more connections in the amygdala, making you more reactive to fear. It can actually shrink your hippocampus, messing with your memory. And it can dial down the activity in your frontal lobe, making it harder to make good decisions. These are real structural changes. So what are we left with? A system that's essential for our survival, but at the same time capable of causing some serious damage. How do we even begin to square that? Well, to do it, we need to completely shift our perspective. This diagram here, it comes from some recent computational research, and it gives us a powerful new way to look at this. It frames the brain not as some passive victim of stress, but as an active agent, an agent that is constantly trying to meet its own internal needs by interpreting and acting on the world around it. And this, right here, brings us to a radical new way of thinking about this whole topic. It's a new theory that casts stress not as a feeling or a malfunction, but as one of the brain's most powerful tools for prediction and adaptation. Now, to get this, we have to understand two key ideas. Most of us probably learned about homeostasis in high school biology. It's reactive. Think of it like a really simple thermostat. It only kicks the heat on after the room gets too cold. But there's a much more advanced concept, elastostasis, which is predictive. This is like a smart thermostat that actually checks the weather forecast and warms the house up before the cold front even arrives. It anticipates what you're going to need to prevent a problem from ever happening in the first place. This whole idea of being predictive is the key to a revolutionary new model of the brain. This theory says that your brain's most fundamental job isn't thinking or feeling or even seeing. No, its primary job, its number one priority, is to be a prediction machine, constantly building a model of the world and guessing what's going to happen next. And if that's true, Here's the punchline. If your brain is a prediction machine, then what we call stress is simply the signal for a prediction error. That's all it is. It's the brain's internal alarm bell screaming, "Whoa, hold on. What is happening right now does not match what I expected to happen. We need to pay attention, update our forecast, and learn from this now." Okay, I know, it's a fascinating idea, but is there any proof? Well, to test it, some researchers built 4 different kinds of computer agents, basically little digital creatures trying to survive in an unpredictable world. Model A was just a basic reactive agent. Model B could learn. But crucially, models C and D were given a stress signal that worked exactly like this prediction error we're talking about. And the results? They are absolutely stunning. The basic agent, Model A, it only survived about 41% of the time. But look at Model C. Just by adding that stress signal, that prediction error, its chances of survival more than doubled to 89%. And when you combine that stress signal with the ability to learn from it, Model D survived nearly 96% of the time. The conclusion is just undeniable. That feeling we call stress was the single most powerful adaptive tool these agents had for staying alive. And this brings us right back to the paradox where we started. Stress isn't just some bug we need to squash, it's a fundamental feature for learning and survival, which really leaves us with one final, and I think really important question to think about. If stress is truly a signal that our predictions about the world are off, how can we get better at actually listening to that signal instead of just trying to shut it off?